mode.
Yes, sir. Please go ahead.
Sri Vishnu Engineering College for Women, Bhimavaram, Andhra Pradesh. Uh, I would like to give a presentation of third in the topic of project-based learning. Presentation on behalf of my team, Dr. Ramarao PVV, Professor and Head EEE Department, Dean R&D of Sri Vishnu Engineering College for Women, and my colleague and hardware exposure, because nowadays coming to our core department, EEE Department, Electrical and Electronics Engineering, most of the in regular conventional method, chalk and board teaching is usually taking place in each and every college. But students are lacking with their practical knowledge, where the main gap is identifying between industry and institution. During mainly we'll get this gap. We can identify this gap clearly when students are attending placements or placement session. In keeping in that view mainly in mind, we in our college have introduced a project-based learning. Particularly in we have started for the subjects power electronics and power semiconductor drives. And this project-based learning is a teaching method in which students can gain more knowledge and skills by working more period than their classroom. Actually, classroom lecture can be restricted per hour for a day, and if we assign the same topic what we have discussed in classroom in form of a project, the student can work apart from their classroom hours. I mean, the student can spend after the college hours in library, in digital library or a library, physical library, where he or she can refer many books, or they can surf technical knowledge by browsing different sites which is been available, and they can explore knowledge, they can gain knowledge, they can discuss among themselves in form of teams to get solution of particular problem. After getting that solution, they'll discuss among themselves, and they'll be interacting with the concerned faculty whether they have gone in a correct way or not. And this particular project-based learning gives practice in using an array of skills needed for their career. How in the time of in a particular problem, how much time they are solving, time management they can be able to manage, and individual responsibility. I mean, if they are if they are working in a team, what is the individual contribution to get the particular solution for a particular problem, and they can have they can learn through personal hands-on experience. And therefore, keeping in these views in mind, in this paper we have highlighted the project-based learning using both simulation and the hardware exposure, and few of the simulation example and few of the hardware process we have presented in this presentation. And as I have said earlier, conventional education is based on lectures and related lab practicals given in the curriculum, and this curriculum also restricted to the affiliated university. And project-based learning is recognized to be motivating and problem-centric teaching that not only supports the students to acquire theoretical knowledge, but also helps the students to transfer that into a real-time application. Actually, mainly coming to the power electronics, in each and every industry, this conversion of power from AC to DC or DC to AC in the required standards is very much required, and power quality issues also main concern. But theoretically, if the students are learning the different converter techniques and control techniques by using of books, and it is very difficult for a student to experience the thing what industry is required. By giving us simple problems and simple circuits to the teacher after explaining that particular topic in classroom, the student can detect the circuit, what are the different power semiconductor devices required to construct that particular circuit, and when to turn on and when to turn off that particular device, and what are the appropriate switch to use in that particular circuit, and what are the different characteristics the device is exhibiting in operating in particular conditions. All these things student can view by using different softwares like PSpace, MATLAB, PSIM, etc. And after working in simulation environment, the student can transfer the same circuit to the hardware by designing PCB boards. And by using PCB board, the student can aware what are the kind of different voltage and current ratings and different frequency ranges, how the components is available in the market, and how the student can gather those components, and how the students can interact with the manufacturers in regarding of some particular application. In all these things can come into real time. Real time while they are experiencing in different types of project. Either it may be mini project or a major project. We in our college is guiding our students to do such a projects in their different subjects, especially in power electronics and drives and circuits. In project-based learning, problem will be assigned to a group of students, and first we'll be forming into different groups based upon the class strength, and each and every group will be assigned a different problem. Unique problem will be given to each and every group, and the group of students themselves, they'll discuss the problem statement and they'll find some solution. Based upon the solution, they themselves will be assigned as particular task to the individual person, and after getting of that, they'll discuss among themselves and they'll get the solution, and they'll be verifying with the instructor. The project-based learning was introduced at SVCW in order to support or partially replace the conventional lectures. The other importance of the PBL method to the courses in the electrical engineering field can raise the challenging spirit for students, and by this means improving their motivation level. The adoption of PBL approach improves student learning, motivation, and communication skills both in oral and report writing. While doing this project, the student can interact among themselves. In that way, the student can interact with the instructors, and the student can interact with the outside world regarding different types of components and different types of facilities they required. In that way, the oral communication may be improved in terms of vocabulary and in terms of technical details also. And at the end of this project, the student is instructed to write a report what they have done during this particular period of time. In that way, the writing skills also improves. Through PBL, students can also improve in self-management, project management, and critical knowledge, positive communication, mutual relationships with the lectures. And the main benefits of PBL is academic research supports the use of project-based learning in college to engage students, reduce absenteeism in the classroom, improve cooperative learning skills, and get better academic performance. I mean, by using this PBL, the student will be really interesting to come to our classes. If we go conventional chalk and board or a simple PPT presentation in our classroom environment, after some time the student may get bored and his concentration may go aside. But by using this project-based learning in regular classroom, not daily, not daily, but in a while, if we go for this project-based learning in all the subjects, the students will be having more interactive with the lectures, and they will be more interesting to know what the thing is happening in the real-time board, and it reduces the absence. PBL project-based learning facilitates more enjoyable and more effective learning. PBL encourages learning from experience allowing students to use and organize what has been learned to understand the problem. After the faculty has been instructed some instruction has been given some instructions or some explanation regarding any topic. After the same topic, if the student has been handled by using a simulation software or by using a lab equipment, or he may constructed or he may do some experiment on it, he'll feel experiencing in industry, and he can understand the problems, real-time problems, what industry people are facing, and if any problem arises during that particular thing, what are the different solutions available to solve that particular problem, and how out of a different number of solutions, which solution can give best results. These are the things the student can understand, and he can experience himself in college environment only. And these all the things can help him to get to settle in his career in a better way. And people project-based learning develops teamwork and communication skills because they have greater control over what and how they learn. Students often feel more interested and responsible for their work. If some particular task has been assigned to the group of students by an instructor, and some target date will be given to the students, and the students, all the team together has to work to get the output of that particular problem or a solution to that particular problem. In that way, the individual student will be feel responsible to complete that work, and the team and teamwork also will be increasing, will be developed among the students once they have step out from the college, and definitely they have to work in a industry with a group of members where the people will come from different regions of the world. And if the students is able to work in a team from college itself, then it is very easy for the student to adapt for different working cultures, and it will be very comfortable for the student when he went outside the college. The main drawback out of these many advantages in project-based learning, the main drawback in project-based learning which we have faced is it takes more time to complete the entire syllabus if you go all the topics in through project-based learning. Because of that, we have to identify what are the main topics which we can go through PBL, and what are the topics which we can go for through video lectures, and what are the topics which we can go through conventional chalk and board, and what are the topics which we can go through group activities by means of chart preparations. All these things we have to identify based upon the syllabus and curriculum, examinations. All these things we have to keep in our mind, and then we have to design this project-based learning to, and we have to adapt that particular methodologies, different teaching methodologies to particular subject. And this is the basic flow chart which a typical project-based learning will follow. First, the teacher will ask a question. Student derive their own directions to take to solve the problem which a teacher or instructor assigned to the group of students. Students will get the solution. After that, student directions, whether they are going in a correct direction, correct path or not. If they went wrong, the instructor will correct them. Students learn information and develop skills. They will, by browsing digital library or surfing or physical library which is available in our college campus. Students apply their knowledge or skills to solve a real world problem. After completing their task, they will apply the same thing to any industrial application, so that they will come to know what is how the things is going in and around the world. Then they are ready to answer more questions where other teams is posing while they are presenting their solution in a classroom or a seminar hall. The other students and other faculty of the department may give their own views, and the students will be able to answer those views. And if you go for based learning methodology in step-by-step execution, the first step, instructor will introduce the problem specifications, and after that, student group analyze. Before step 1, we will be dividing the entire entire class strength into different groups, number of groups based upon the head count in the class. After that is the given problem. Next is a proper power. If some converter or a rectifier, or if converter has to be designed by the some particular group, then they have to, the group has to identify proper power semiconductor switch selection, and next check different power semiconductor switches and analyze the characteristics of the switch by collecting the data sheets and generate report. In market, if you go for IGBT can be available for different switching frequencies and different voltage ratings. Based upon the our application and our range, we can get the IGBTs of same rating from different manufacturers, and we can download all the data sheets of that particular manufacturers, and we can check the characteristics of the particular switch which we are going to use, and we can compare different manufacturers characteristics, and we can select we can generate a report, we can write a report, whatever we have understand, I mean whatever students have understand from the reports, and they can generate the report, and that report may be discussed with the instructor or a particular subject teacher expert, and based upon the impression given by the subject expert, they may go ahead. And after that, get the feedback from the instructor and formulate the solution. And second criteria is topology, and discuss once the proper semiconductor switch has been selected, and they'll go for topology. Topology means the same operation, same output can be maybe get from different types of circuit configurations, out of which circuit configuration is given better output, with decreased number of switch count, and better efficiency, and discuss and work out for different circuit configurations where the results are effective, the layout size, cost. If the total number of switch count has been decreased for each and every semiconductor switch, we require one gate drive to turn on and turn off, and so that if the number of IGBTs has been, or a MOSFETs or anything has been, power semiconductor switch has been decreasing, the concerned gate driver circuit will be reduced, and the power supply required to gate driver and particular switch has been reduced, so that the complexity of construction of the entire topology has been decreases, and the efficiency will be increased. And get the feedback from the instructor, and each and every criteria, after completion of each and every criteria, before the students group has been implementing in their own way, the students group will be taking the individual subject expert decision or impression on the, based upon the impression given by the subject expert, or will go for constructing and analyzing the results. And third criteria in power electronics, will go for control technique. Deriving this control technique is modulation technique to generate the gate pulses to the power semiconductor switches. For this thing, there are many PWM techniques for low frequency PWM technique, high frequency PWM technique. For this thing, again the same thing will be taking place. To derive the switching pulses based upon the switch we have selected in first criteria, and based upon the topology, I mean that is nothing but configuration which we have selected in the second criteria. Based upon keeping in mind these two, first criteria and second criteria, the student should analyze which control technique should add correctly to get the correct output, and getting based upon that, in third criteria, the control technique can be derived by the student group. After that, the same procedure will be repeated for a selection of load and all these things. And first, the student, before going to the hardware exposure, first they will be simulating by using different simulation tool which is being convenient for the student, and which will be suitable for the particular assignment. And finally, after simulating, they'll get the results. They derive, analyze the results: output voltage waveform, current waveform, THD, all whatever thing is required, and they'll prepare final documentation and present individually in the classroom. And once then the same thing can be carried out in hardware environment also. And this is the simple simulation example which we would like to show here for sine PWM based split phase induction motor. In this particular example, or in this particular assignment which we have given for third year triple E students and first year MTech students, where they will be studying all power electronics and power semiconductor subjects. And this assignment will be given to the third year BTech students once they have completed power electronics and they step into the power semiconductor stress. In this particular case, the students can able to analyze the speed torque characteristics of the induction motor, and the student can able to construct the inverter circuit, and the student can able to derive the DC source from the available AC source with the help of a diode rectifier, and after that they will be selecting a proper capacitor to reduce the ripple content in the rectifier output. And after that, we will be deriving the switching pulses to the inverter circuit to operate in a proper way to get the alternating waveform, and the alternating waveform will be given to the split phase induction motor. Before giving the input to the split phase induction motor, I mean single phase induction motor, the student can analyze the output waveform of output voltage and current waveform of an inverter by using a FFT analysis, which the thing will be the thing is available in a power view. This particular thing, by using this power view, the students can go for fast Fourier transform analysis of any signal coming from the output, so that the total harmonic distortion, the total harmonic distortion can be analyzed by the student. If the distortion is high, then the student may rethink whether the circuit configuration may have to change, or he has to change the control technique. I mean nothing but a modulation technique. And by selecting this, by changing one or the other, and the students will go further analysis, and they compare the THD with the previous thing, and they'll come to conclusion which control methodology is fine for to get the less THD percentage, which is suitable, which is where the less distortion is available in a sinusoidal waveform. Where nowadays all the industry, each and every electrical appliance required to use sinusoidal waveform with less harmonic distortion. And these are the simulation results we have students have observed. After getting these are the simulation results we have observed of the student project. This is the diode rectifier output before filter, and this is the inverter output, and this is the rotor speed waveform, and this is the electromagnetic torque and main winding current. And this is the simple experiment which we had in our R&D lab, power and energy lab in IEEE department, where the student can work for V/F control, voltage frequency control using DSP controller. And by using this experiment, we'll train the student how they can code by using a digital controller like Arduino microcontroller and FPGA and DSP. These are the different kits, different digital controls available in our college in electrical and electronics department, and and we have different faculty also. We have many faculty who are working working in real time by using this particular controllers. Then they will guide the students and how to write a program, and based upon the control, based upon the strategy, based upon the logic, the thing. And after that, they'll find the induction motor speed torque characteristics by using the power quality analyzer that is also available in our laboratory. By using power quality analyzer, the student can get more data, real-time data, where the industry people are using the same power quality analyzer. And this is the photograph which we have taken while our senior associate professor Miss Padmaja Madam is explaining about 7-level multi-level cascaded multi-level inverter. And by using this project, we have two of the BTech final year academic projects has been taken. Two of the final year BTech projects has been spent there 6 months of time on this project, and three MTech projects has been three students has been spent their 1 year span of time to complete their MTech projects, and they and each and every batch have been directed or instructed to work with same inverter power module, but the control strategies has been differing from each and every batch. And by using this, by differing the different control strategy, the output will be definitely will be varying, and based upon that, the student can analyze from each and other, based upon the output derived from each and every batch. And one more opportunity our management or Sri Vishnu Engineering College for Women is provided is here in our college campus we have assistive technology lab, ATL lab, where each and all the second year and third year students will spend their time throughout the thing to develop products for physically challenging people. And this for example, here we are showing a simple product, tremor operator. This is the product developed by IEEE students in ATL lab with the help of our EC faculty and the IEEE faculty. And these are the things, these are the report generated by the student, and these are the things the student multidisciplinary. This is the multidisciplinary project where the mingle of CSE people, ECE people, and electrical people, students will involve in this particular project. And presentation skills can be improved, and handling components, how to select different types of ratings or different types of components out of many components available in market, and technical and logical thinking. Circuit implementation is nothing but circuit implementation. Applying fundamentals is nothing but whether the whether the end result is correct or not. How the student can identify whether the derived thing output is correct or not. Wide knowledge on electronic components, inserting new components, existing circuit for easy product design, solving outer case design, handy use. All these things can be handled by the students. And teamwork, soft skills acquired by the students by doing this type of projects. And analyzing skills, time management, completing the entire project in a stipulated time, fastness and spontaneity in work, surfing internet to different economic websites, professionalism in work, documentation, record maintenance, everything, fast uses of MS Office presentations and documentation, and teamwork. It's nothing but a patience which our students have quoted here. Electrical and electronics engineering contribution. Our department, department contribution in this particular project is they have fundamental laws like Ohm's law, all these things which I have studied in the first year are interpreted, and after that microprocessor and microcontroller for characteristics, and from this particular subject which they will be studying in 3-2, the concepts of different characteristics and pin configurations and programming of in entire logic by using digital controller. And after that, electronic devices and circuits, this is the subject they have been studied, and from this particular subject they have used the concepts of basic operation of diodes and transistors, linear and digital integrated circuits. From this they have used the concepts of op-amps, operational amplifiers, analog to digital and digital to analog conversion, and from circuit analysis, voltage division, current division rules, KVL, KCL, all these things, and pulse and digital circuits. From this, what are the active filter, low pass filter, high pass filter, input waveforms, all. From switching, STLD, switching theory and logic design, how to generate, reset the things, clock signals, all these things. From MEFA, budget, management science, teamwork, and leadership skills. These are the different subjects which the students have identified after completion of this particular project, and what are the different concepts they have been utilized from that particular subject. This project idea is to design a device which assists hearing and speech challenged people and convey their message to others. And this is the smart shoe for visually challenged, and this is the project to provide visually challenged people a device which can help them to avoid obstacles while working. And in the same way here also the people, our students have been generated after completion of this project. What are the subjects they have helped, what are the subjects they have, and what are the concepts from that particular subject they have used to complete this particular project. And after this is the Pico, this the Pico hydro power plant which our students has been working on this. From past 3 years, stage by stage, our students is working on this particular plant, and they're increasing the output power. And this is the structured framework for handling design nonlinearity. And this is the system knowledge gained implementing the concept practically through identification, creativity, creative synthesis, and evaluation. And these are the soft skills acquired by the students. And electrical circuit analysis, physics, power electronics, missions, and management science. These are the subjects helped to the students to complete this particular project. And this is the group activities which is being carried in the classroom, apart from their conventional or traditional chalk and board or teaching, apart from PBL also, project-based learning also. And the entire class strength has been divided into different teams, and different assignments will be given to the teams. And the same team, the same assignment or topic will be discussed among the groups, and they will be preparing different charts. I mean, block diagram, advantage, disadvantage, application, whatever the stuff required the particular task. And after that, after a particular period of time, the students will gather themselves and they will be presenting the same thing in the class. By using this type of activities, students can improve their oral skills, written skills, and the team, how to mingle among themselves and how to interact to get the correct solution for a particular problem. And this is the group discussion we have carried out. The photo shown here in this particular presentation is for microprocessor and microcontroller subject. And this is the block designed by the students of 3rd BTech BBA students, where the student will be given all the data which has been, what are the things and what are the what are the activities is taking place in the particular subject. And each and every student will be having their own block, and they'll be posting of all the activities which that particular student has been has been participated throughout this semester. And as of now, they have completed only for 8 weeks of instruction classes as of now. And these are the things, assignments and group activities, all the group discussions which we have taken place in the classroom. And initially they will be having the basic information about the particular students, what are the activities, co-curricular activities, extracurricular activities of that particular student is participating in and out of our institution. And after completion of this project-based learning for power electronics and power semiconductor tests, a sample questionnaire, sample evaluation has been has been given to the students in the form of a 9 questions. We have designed in form of 9 questions, and these are the 9 questions which are given questionnaire. And E, G, A, P, and C is nothing but excellent, good, average, poor, and no comment. And these are the grades, different grades, which has been ranked by using 5 to 1 scaling. After this survey, after the survey has been taken from one particular batch, this project-based learning and group discussion activities, and in the form of a video lectures, the student involvement will be is a teaching methodology, delivery methodology, or a teaching methodology in the classrooms. And student is more interestingly participating in is interacting with the instructors and lecturers, and getting different particular solutions, out of which they are getting one particular, they are selecting one particular solution out of many solutions from many people. And apart from this, many our college also inviting many industrial experts to deliver their guest lectures and seminars in of that particular subject, and by using that, by means of that, students can understand and what are the real-time problems the industrial people are facing in their working atmosphere. And these are the graph which we have taken out of a sample survey before PBL, project-based learning, and after project-based learning. And this graph shows we have a very good result for project-based learning while after implementation of this PBL. In this paper, here I would like to conclude this presentation, and in this paper we tried to show how effective the effectiveness of the project-based learning in the classroom environment, how the student can interact with the lectures, how the student can mingle, how effectively the student, how interestingly the student will involve to acquire knowledge of the particular student. And the survey results before and after PBL also shows the student interested in learning the concepts using simulation software rather than the regular chalk and board methodology. And I'm very thankful for giving me this opportunity. Thank you. Hello.
Yes, sir.
So, any queries, sir?
PBL means, is it only for project? I want to implement PBL for digital signal processing subject. What way can I plan?
No, this particular thing, project-based learning can be implemented for any subject where the different mini process easily can be carried out. If you go for some particular subjects where there is a period of 5, hardly will be getting only 4.5 months if you take out of this mid examination, internal examination, all those things. And if you go for a bigger, huge projects, it's very difficult to wind up our syllabus also. Therefore, for few subjects, it's very good. And regarding all these subjects, we have to think of based upon our curriculum designing and all these things. Here in our college, we are planning. We have implemented this for power electronics and power semiconductor test and electrical circuit analysis. As of now, these 3 subjects is taking place, sir.
Thank you, sir. We give them one more minute in case.
Okay, thank you. How it should be
dealt. Do I need to start with project?
No, first we should not start directly through the project. First, that particular any out of the if you take this particular simple this power electronics subject only, after explaining of this off-air rectifier, and for example, I'm saying this particular this the half rectifier or a full rectifier circuit. After explaining the circuit operation chuck and board, we can assign this particular task to one group of students. The students first they'll do this work work out in on paper, and they'll simulate by using any simulation software, either MATLAB, PSIM, or PSpace. PSpace. After that, they can go for real-time implementation, sir. During real-time implementation, if they face any problem, it is very difficult to wind up the project. If the same thing has been taking place before going to real-time implementation, if they go for software, easy for the students to identify the difficulties arising in constructing or completing of that particular project, and whether the result is proper way output is in a designed manner or not. If the output is not in a designed manner, in simulation environment, the students can easily modify as they can. Therefore, before going to real-time or project directly to the project, it's better to work it out in on paper first, and then simulation, then
How is it implemented for diploma students?
Dipl uh, dip for diploma students, it's somewhat difficult to go for simulation environment in that case, sir. But they'll be having by using the equipment of lab equipment, we can explain the concepts of theoretical concepts, sir. Apart after explaining particular concept theoretically in classroom, we can take a group of students, not entire all the students at a time. We can form different 5 to 10 students in a batch. We can take those students to the lab, regular lab, curriculum lab, and if that particular equipment is available in the particular lab, we can show physically how the particular machine or a circuit is operating under various conditions. In that way, we can give this particular knowledge to the diploma student.
Thank you very much, sir, for the presentation. That was all the questions.
Okay, sir. Thank you, sir. Thank you for giving this opportunity, sir. Thank you.